The topic to be discussed is probability of an undetected error for linear codes over a BSC. BSC means binary symmetric channel. Binary means either information is in the form of zeros, one, consists of either zeros or ones. Symmetric, two-way, symmetric channel. When a code word is transmitted through a binary symmetric channel BSC, some bits may change from 0 to 1 or from 1 to 0. This one is encoder, transmitting side, decoder, receiver side, binary symmetric channel. From the encoder, 0 is transmitted and 0 is received correctly with a probability 1 minus p. Suppose 0 is transmitted, instead of 0 is received, 1 is received with a probability p. Suppose 1 is transmitted, 1 is received with a probability 1 minus p. 1 is transmitted, instead of 1 is received, 0 is received. That is, the bit is flipped from 1 to 0 with a probability p. This is the error. It indicates some error. Crossover probability means 0 is transmitted, but 1 is received with a probability p. 1 is transmitted, 0 is received with a probability p. That is called as a crossover probability. Cross means 0 is transmitted, instead of 0, 1 is received. This is the cross one. 1 is transmitted, instead of 1 is received, 0 is received. This is cross one. With a probability p in both the cases. That is called as crossover probability. Next, coming to correct transmission means 0 is transmitted, 0 is received with a probability 1 minus p. 1 is transmitted, 1 is received with a probability 1 minus p. This is the binary symmetric. 0 is transmitted, 0 is received, 0 is transmitted, 1 is received. 1 is transmitted, 0 is received, 1 is transmitted, 1 is received. The receiver uses the parity check matrix H to detect errors. This is the channel, binary symmetric channel. This is the receiver, transmitter. The receiver uses the parity check matrix, capital H, Q cross N. Suppose the transmitted code word is X. Suppose the transmitted code word is X. If no bit changes during the transmission, the received word is Y. The received code word is Y. Transmitted code word is same as received code word is same as the transmitted code word. Find out the syndrome. Syndrome is equal to Y into H transpose. Y into H transpose is equal to 0. Hence, the receiver concludes that there is no error. Case 1. In case 2, suppose 1 bit changes during the transmission. Received code word is different from the transmitted code word. That is Y not equal to X. Now calculate S. S is equal to Y into H transpose not is equal to 0. The receiver detects that an error has occurred. If S is equal to some non-zero vector, that means some value goes of the H transpose, the receiver detects that an error has occurred. In case 3, undetected error. Our concentration is on this undetected error. Sometimes the error pattern itself is another valid code word. Suppose 0, 0, 0, 0, 1, 2, 3, 4, 5, 6. This is the 7-bit error vector. 7-bit error vector. The 7-bit error vector, sometimes this error vector is also appeared. Another valid code word is also in the form of error vector. Sometimes valid code word vector is also in the form of this error vector. Suppose Y is equal to X plus C. received code word is equal X plus E. Generally, E is error pattern, but in this case, E is valid code word. Valid code word. Appearance of E is in the form of valid code word. That code word is appeared at the output. Okay, where E is the error pattern. E also belongs to X. Thinking of that receiver is E also belongs to transmitted code word. Calculate syndrome with the receiver side Y into H transpose. Y is equal X plus E into H transpose. X into H transpose, E into H transpose. Both X and E are code words in this case. Generally, X is not a code word, but it is an error pattern. In that case, E is also treated as a code word. These two are valid code words. X into H transpose is equal to 0. E into H transpose is equal to 0. S is equal to 0. S is equal to 0. The receiver thinking is that there is no transmitted error, but E is received. Error vector is received. The receiver assumes that no error has occurred, even though errors are present. Even though errors are present means transmission error vector is in the form of valid code word. Error vector is in the form of valid code word. Therefore, error vector is also received along with the valid code word X. That is the reason an error is detected. This is called as undetected error. Even S is equal to 0, some undetected error is there because error vector is the same as valid code word vector. Error vector is same as valid code word vector. Procedure to detect the probability of that undetected error. The title of that discussion is probability of an undetected error for linear codes over a binary symmetric channel. Undetected error. Probability of that undetected error procedure. Procedure means suppose generate with the help of generator matrix, code word X is generated. Code word X is generated. Generator matrix is converted into H matrix. H matrix is converted into dual code of N comma K LBC. Later I will explain importance of this dual code. X is the linear block code of N comma K. H is called as a parity check matrix. G is called as a generator matrix. X the symbol indicates X symbol indicates the dual code of capital X. Dual code of capital X. The rows of the parity check matrix H generates the dual code X cap. The rows of the parity check matrix H generates the dual code X cap. Suppose X is the capital X is the linear block code. It is represented by N comma K. G is the generator matrix. H is the parity check matrix. The rows of H matrix. Suppose 3 rows are there. Row 1 plus C1, C2, C3. The dual code of X is X cap is formed by C1, C2, C3, C1 plus C2, C1, C1 plus C2, C2 plus C3, C2 plus 3, C3, and C1 plus C3, C1 plus C2 plus C3. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3. C1, C2, C3. C1 plus C2. C1 plus C2. C1 plus C3. C2 plus C3. C1 plus C2 plus C3. Suppose H matrix dimension is Q cross N. Therefore, the number of code words dual code words are, the number of dual code words are 2 power q. 2 power q means q is equal to n minus k. Suppose 7 comma 4, q is equal to 7 minus 4, that is equal to 3. 2 cube, that is equal to 8 dual codes are obtained. 8 dual codes are generated from this parity check matrix. Find the dual code is very, very important. The rows of the parity check matrix H generates the dual code. In this example, the rows are represented by C1, C2, C3. Next, G generates the original code X. H generates the dual code X bar, X cap. Every code word in X is orthogonal, every code word in X cap. Every code word in X is orthogonal to every code word in X cap. The dual code is generated by the parity check matrix of linear block code. Parity check matrix play an important role for the generation of that dual code. The dual code helps to determine whether the received word contains error or not. The number of dual code words are 2 power q, 2 power n minus k. Suppose G generates X. Suppose 7 comma 4. 7 comma 4 means 2 power 4, 16 encoded code words are there. In case of dual code, only 2 cube, 2 power q. Q means 7 minus 4, 3. Only 2 cube, 8 encoded code words are enough to analyze the probability of undetected errors. Probability of undetected errors. Next step is first step determination of dual code. Second step is determine the weight distribution. Find all code words of the dual code. Suppose 7 comma 4 is the linear block code of, that means linear block code X. Dual code is represented by X cap. 2 cube, 8. 8 codes are there. Code words. These are the 8 code words of the dual code. These are the 8 code words of the dual code X cap. And found the number of code words corresponding to each weight. Found the number of codes corresponding to each weight. Let BI is equal to number of code words of weight I. BI is the number of code words of weight I. Suppose 0, 0, 0, 0. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Weight of this code word is 0. Only 1 is there. Suppose 0, 1, 0, 0, 0, 1. Weight of this code is 2. Suppose 0, 0, 1, 0, 0, 1. Weight of this code is 2. Therefore, 2 weight code words are 2. 0 weight code word is 1. It indicates BI is the number of code words of weight I. Number of code words of weight I. In first case, weight is 0. Only 1 code word is there. In second case, weight is 2. Only 2 code words are there. And so on and so forth. Step 3. Write the weight enumerator polynomial. The weight enumerator polynomial is B0 plus B1z plus B2z square plus so on and so forth, Bnz whole power n, where I is equal to 0, 1, 2, 3 up to n. Suppose weight is 1, weight is 1, 3 code words are there. Therefore, here 3z. 3z is the polynomial form. Suppose weight is 2, 4 code words are there. That means 4 z square. Like that. The representation is like that. Step 4. Probability of an undetected error for n comma k linear code is PU of E, undetected error. U means undetected, E means error. is equal to general formula is need not derive this expression 2 power minus n minus k. N minus k means q. B of 1 minus 2p minus 1 minus p whole power n. Please remember this expression. No need to derive this expression. Valid expression, general expression, Macmillan's expression. N is called as a code length, number of bits in the code word. K is called as a number of message bits. P is called as a bit error probability of a binary symmetric channel. Where P is called as bit error probability. Instead of 1, 0 is received. Instead of 0, 1 is received. Bit error probability of BSC. In case of already explained this one, with the 0 is sent, 1 is received with the probability P. 1 is sent, 0 is received with the probability P. That is called as bit error probability of the binary symmetric channel. BZ. BZ is the weight enumerator of the dual code. Weight enumerator of the dual code. Z is equal to 1 minus 2. Later I will discuss. There are some important terms involved in probability of undetected error of the linear blackboards. 1 minus p whole power n. This is the 1 minus p whole power n represents the probability that all n bits are received correctly. 0 is, suppose 0 is sent, 0 is received, 1 is sent, 1 is received. In the binary symmetric channel, 0 is sent, 0 is received with a probability 1 minus p, 1 is sent, 1 is received with the probability 1 minus p. Whole power n. Whole power n means so many vectors are, so many bits are there here at the input side. 1 minus p whole power n represents the probability that all n bits are received correctly. Second one is bz, b of z. The weight enumerator is b of z is equal to b naught plus b1z plus b2z square plus so on and so forth, bn z power n. Consider code words of the dual code. Consider code words of the dual codes and find out the weights of all these code words of the dual codes. Suppose the weight of some code words are 4. Therefore, a weight enumerator function is b4 z power 4. b4 z power 4. Where bi is the number of code words having weight I. Number of code words. Bi is the number of code words having weight I. B of 1 minus zp. B of 1 minus zp. 2p, not zp. This is the 2p. Replace with z with 1 minus 2p. This term incorporated effects of channel errors. Channel errors. B of 1 minus 2p represents channel errors. Channel error. 1 minus p means bits are correctly received. Whatever the bits are transmitted from the transmitter, same bits are appeared at the receiver. This is the one B of 1 minus 2p represents, this term represents channel errors. Here 2 power minus q. Q represents number of parity bits. Since q is equal to n minus 2, the factor is depends on the number of parity bits. The weight enumerator is bz is b naught plus b1z plus b2z square plus bn z power n. B naught, the number of code words with weight 0. Number of code words with weight 1, number of code words with weight 2, number of code words with weight n. Suppose in the 2 cube 7 comma 4, 2 cube 2 power q dual codes are there. Code not dual codes, 2 cube, that means 8 code words are present in dual code. Out of these 8 code words, weights are 0 weight is one code word. 1, 2, 3, 4, 5, 6, 7. The remaining 0 to 7, 0 to 7, 0 to 6, not 7, 0 to 6. The remaining code words of the dual code weight is 4. The enumerator function is bz 1 into b naught plus 4 code words are there, four words with vi is 4, I is 4, that is e power 4. This is the enumerator function. This is the enumerator function. With this, the analysis is completed.